Welcome to Roads Australia's policy webinar. Before going any further, I'd like to start by acknowledging the traditional owners of the land. We pay our respects to their elders past, present and emerging. We'd also like to thank representatives of RA's patrons who are in attendance today, from Arcadis, Arup, Oricon, Stantec, GHD and CPV contractors. Welcome everyone, my name is Chloe Robertson and I'm a policy officer here at Roads Australia. As a principal partner of National Road Safety Week, RA, in partnership with Altus Traffic, is proud to be holding this webinar today during National Road Safety Week. It's an annual initiative from the Safer Australian Roads and Highways Group, partnering road safety organisations and government. The week highlights the impact of road trauma and ways to reduce it. Today's theme is protecting all vulnerable road users, especially those whose job places them in harm's way, by slowing down and giving them the space they need to be safe. Every year, approximately 1,200 people are killed and another 44,000 are seriously injured on Australian roads. Traffic injury is the biggest killer of Australian children under 15 and the second biggest killer of all Australians aged between 15 and 24. Safety is RA's #1 policy priority, with a focus on improving the safety of those who work on our roads. Safety has no IP, which is why, with our sponsor today, we can share this important information to a wider audience. This webinar will explore the sources and types of data available to contextualise site-specific risks facing road workers and how data can empower organisations in their approach to risk mitigation and the safety of their people. Moderating today's discussion will be James Pennings, Chief Commercial Officer at Altus Traffic, and a member of RA's Road Worker Safety Working Group. Over to you, James.
Hey, thanks, Chloe. And let me add my welcome to Chloe's to everyone who's joining us to discuss this important topic today from wherever you come from, wherever you're joining us from. I'm in Perth at the moment. I've been here for a series of National Road Safety Week events, starting with the official launch at Government House on Sunday evening. And I'm not long back from an industry breakfast this morning with a whole range of representatives across industry, around 200 or so. And I think we've got something like that in terms of the registrations for this webinar. So it's great to see the interest that's being shown in what is such an important topic. And what I can say is, having been involved as a principal partner in National Road Safety Week now for 8 years, is that the discussion around road worker safety has become very, very central to the messaging. So we want to see that continue. Today, my pleasure to bring you some great panelists in what I hope will be a very interesting set of presentations that just might get you thinking about risk a little differently. Each of our panelists are building out solutions that will, and indeed already are, creating new use cases in support of road safety generally and road worker safety in particular. The theme of these presentations, as Chloe touched on, is digitising risk and how these respective solutions can better contextualise the risks associated with working on our roads. So without further ado, let me introduce our first panellist, joining us, I think, from Hong Kong, all the way from Hong Kong. Welcome, Angus. Angus is a founding director of Compass IoT, a multi-award-winning road intelligence company that uses connected vehicle data to help transport professionals build better, safer cities. A serial entrepreneur with over 6 years of experience building tech-enabled mobility businesses, Angus was awarded a TCCS Director General Award in 2019 and Best Established Startup at the UTS Startup Awards in 2022. Compass IoT was awarded a Google Cloud Customer Award in 2022 for using data to prioritise road maintenance and repair after the 2022 Lismore floods. And whilst Angus prepares to transition his presentation to the screen, I would just let everyone know that there is an opportunity to ask questions. Don't use the chat feature in Zoom, use the Q&A feature in Zoom. And what we will do is look to get to those questions at the conclusion of our final presentation. Over to you, Angus.
Okay, thanks, James. And thanks everyone for giving us the opportunity to talk about how connected vehicle data is being used to improve road safety. So it was a really nice introduction, as James said, my name's Angus. I'm one of the directors of Compass IoT. And I suppose when we look at the world, there was sort of different gaps. We've got Nearmap on the call who sort of zooms in and is able to look at infrastructure very granularly. We have a big business in Australia of like surveying roads. That's largely around like tube counts, camera counts, etc. Even the ARRB vehicles that run around with cameras on them. And I suppose when we formed Compass, the key understanding or the key thing that we were looking to do was to use the car as the sensor, the car or the truck or the bus. Because nowadays, more and more, if you think about like Tesla, for example, or indeed just Toyotas and Fords and general vehicles, they're now not much more than software and four wheels. Indeed, all of them are going electric soon as well. And so what we've done is we've essentially made agreements with the vehicle manufacturers. There's about 60 in total now. And that allows us to understand swerving, braking, speed, and other variables wide. So, I mean, I'm about to do an example of a construction site on the M7, but it doesn't really matter whether you're looking at Mount Isa in regional rural Australia, or whether you're looking at metropolitan Sydney, Melbourne, or Brisbane, or indeed Perth. There is connected vehicle data running across the road network today at scale. So what we do is we enable that data to be analysed. So here you can see that we're looking at an exit to the Rooty Hill off-ramp. This was one that had persistent rear-to-end crashes. And so what we were looking for when we looked at this site was a series of information. The speeds looked okay, but now that we get vehicle performance in their swerving and braking, we can have a bit of a deeper look. The reason we get this again is because we write code for the head units of cars. What does that mean? It means that buy a new Ford or Toyota or Tesla or Jeep Chrysler, for example, or indeed Kia's just launched theirs, MG's just launched theirs, BMW, etc. They have accelerometers, they have SIM cards that are able to transmit this data to the cloud, and Compass then uses that and gives it to road planners so that they can understand their network better. At this little section, for example, you can see, obviously this is your speed distribution. You can see that the braking's not too bad, but we do get this really interesting cluster up the top for a right-hand swerve. Now, why would a right-hand swerve be going on a straight section of road network? We can actually take a look at this section of road and it gives us a better understanding. So this is the Rooty Hill off-ramp. You can see here 110 kilometers an hour posted speed limit. And vehicles are going to the left. You get off, but straight if they're going straight ahead. So in theory, there should be no right-hand swerve. The reason we get to see this data is because vehicles are trying to swerve into the right-hand lane to avoid the back of queue. That is, the back of the queue is going and spilling into the main line off the Rooty Hill off-ramp. Let's take a look at this more deeply. Here are a series of what we call near misses. This is when vehicles are losing friction with the road surface. They come in real time, and we can see here a pattern, largely that it's happening in the AM peak. And so each one of these vehicles is slamming on the brakes and losing friction with that road surface. You can see here, this is Feb 28, 2023. This one's in the morning, 2022, November. And this one's again in the morning, 2022, April. Misses are an indicator of risk. They don't equal a crash, but they equal an increased risk, because where you see vehicles slamming on the brakes or swerving violently and losing friction with the road surface, we can better understand where those violent behaviors are and isolate them before a crash occurs. Normally, particularly with roadwork sites, you don't get too many chances. The short answer is generally that once you set up a roadworking site, you only know if it's failed if something has occurred. These near misses give us a proactive measure of safety. And lastly, I just wanted to show quickly what this resulted in. So this particular use case was a transurban use case. The back of queue was very clear. and the swerving braking profile was very clear. And they were able to change the signaling to get more vehicles off the Rudy Hill off and then back onto the main line. This sort of example is where connected vehicle data is being used to improve road safety. I'll pass back to you, James.
Thanks, Angus. And I might just follow up with a question or two on that. What would have been the analog method of identifying that issue before this solution was available?
Back in the day, I suppose a lot of this work would be done with cameras, but you'd have to have crash history to begin with. So you'd never put cameras across the entire road network, particularly regional or rural areas. Whereas now you have the ability to see where this behavior is happening network wide. And particularly if you're setting up a construction site, you've got essentially a change in traffic conditions that's a green space. And so cameras could work, but it's a pretty expensive option when something like this runs passively.
And then just secondly, before we move to Roger, you spoke of a number of vehicle brands that were becoming more able to communicate data in real time. What are the statistics around sample size of the fleet? And perhaps what are the sort of trend changes we're seeing? At what point will we have a large critical mass of vehicles as sensors?
We're now at about 5 to 10% of all vehicles on the road, depending on where you are. So in regional rural, it's slightly less, and then in metro, it's slightly more. That's generally enough to get a good understanding of safety. It's not every single vehicle, so you miss, some, but it's enough to get a good understanding of trends. And it's definitely enough to have a proactive measure like near misses, for example, or indeed just swerving braking vehicle behavior in general. I don't know if it'll ever get to 100%, but long-term, even very basic vehicles, the Toyota Camry, for example, Kia, Hyundai, they're all becoming connected, even MG. So I think long-term, it will be a very, very high percentage of vehicles. And we're seeing the data set double year on year, pretty much ever since we started.
Excellent. And if you do have some questions for Angus, again, I'd remind you have that Q&A function to drop that in, and we'll look to get to those questions towards the end of the webinar. All right, thank you, Angus. I might switch now to Roger Poth and give him a introduction. So Roger has been involved in the development and commercialization of new ideas and technologies for over 20 years now. He's also a Dutchman. He co-founded Highway Resource Solutions in 2011 following the death of a road worker in the UK. This tragic incident caused by an errant vehicle entering a road work site was the catalyst for the development of an incursion warning system for road workers, which is now recognised as best practice in the UK with more than 18,000 deployments last year alone. Today's HRS myworkzones.com Internet of Things platform underpins a range of work zone focused digital services that help to keep road workers safe, improve efficiency and reduce carbon emissions associated with work zone management. Over to you, Roger.
Thank you, James. As James has alluded to, business has been around we've been around for about 10 years, and unfortunately, the way we started the business was on the back of a fatality in the UK, where somebody got killed who was working in a supposedly, safe environment, which was a road closure. And that led us to start developing systems that could help people at the coalface. So our approach has been really focusing on, from the ground up, what can we do for the workforce? Because as James alluded to, in the past, there's been a lot of focus on the safety of road user, and rightly so. But the people that we put at risk, we need to look after them in equal measure. So it's really good to see the focus in Road Safety Week on road workers. So that's basically where we started off, and looking at how we could build a safe perimeter around work zones. So if somebody breaches them, we could warn people. Pretty quickly, we ran into, or stumbled into, shall I say, the early stage of industrial IoT, so Internet of Things connectivity, and we started to build a platform around that. As James said, we're now quite well spread in the UK. This is considered best practice by highway authorities on a national level, and also on a local level where our solutions are deployed. And we've basically created a category that is called incursion warning systems that is recognized. Our approach, as I said, it's from the ground up. It's tangible devices that warn people on site, but we've had to build a back-end system. That back-end system is basically underpinning everything we do. And what we've done is we've built an ecosystem that makes it really easy for people on site to use it. In most cases in the UK, they wouldn't even know what equipment was on site because it's integrated into existing traffic control equipment like cones, lamps, those sorts of things. But one of the fundamental breakthroughs for us was to create a digital layer or a geozone that we associated with a real live work site. That is created in our backend system, and the equipment, when it's deployed, operates in a fully automated way. That also allows us to capture an awful lot of data and store it based on what work zone was deployed. So it is literally corresponding with the works that are taking place. So for an authority or for a traffic control company, they can really easily manage the equipment they deploy, but also the data they get back and analyze that. And I'll give a few examples at the end of that as well. So for us, the whole back end is, we call it smart geozones equals smart work zones. First of all, by creating that digital layer, like I said, we can start at looking when, where, and what. Secondly, when equipment is deployed, it automates the way it functions. So people are at the call phase, the maximum they ever have to do is press a button. What we've also seen is we've been able to use that data once it is deployed to give you a live, real up-to-date status of when work zones are deployed. There's been a lot of complaints in the UK with people, actually road users, getting fed up with roadworks because they don't know exactly where and when they take place. So there might be a lot of signage out, but there is nothing really happening. And again, that causes issues. We've seen issues where we do a lot of full closures overnight, full carriageway closures, where people get frustrated around diversion routes and things like that. And what we've been able to do with the data that our equipment provides is feed that into, for example, CITS systems, and in the future V2X, or direct communication to road users, so they're better informed and less likely to incur into work sites as well. The data that we get back and we share with our clients shows things like how many incursions happened, which is picked up by our equipment, where did they happen, have we got hotspots, should we change the design of the traffic management, maybe use more signage, those sorts of things can be derived from that. And all of that is also available to people on the site to, via an app. So that's the back-end system. The actual physical equipment that is used, there's an example here on the picture on the right-hand side. It's a gateway device connected to the internet that is a loud audio-visual alarm unit that sits in the work area. Of those, we have on a daily basis 600 or 700 deployed in the UK alone, and they're taken to site by work crews and they connect to sensors around the perimeter. And I'll show a few examples in a minute. What we've been able to do with this is, first of all, improve safety massively. Weekly, we get reports from people to say that this has made a real difference to them. We've also been able to look at operational efficiency. So on some really big full closures in the UK, sometimes we would need 40, 50 traffic controllers. This is not about, getting rid of jobs. This is about allowing people to work smarter. So where we close a road, abuse happens sometimes where people are not very happy. They challenge the people they can see. And what we've been able to do with the technology is to build a perimeter that detects an incursion and move people to a more safer position. Likewise, some of the technology we've got has helped reduce the inspections needed of traffic management. We can do it remotely, and that reduces carbon emissions. Don't want to go into how it works in too much detail, but just to show you the modularity of it, these devices are just simply placed where people are working, and they connect to sensors around them. And those sensors could either be integrated into cones or cone lamps with impact technology, or we use laser beams that we strategically place around the work zone. When they are triggered, they will activate alarms in the work areas. And because of our geozoning technology, there is absolutely no issue with range or reach. So it's quite seamless from that perspective. Then the actual data that comes out of this platform. like I said earlier, we get data on deployment, which is really important for our stakeholders, but we also look at what is actually happening with regards to intrusions. So the previous speaker, Angus, he said, look, you can anticipate where there's a problem with your traffic control. This is more about where do we have actual incidents. So you look at near misses, but where do you have actual intrusions, or where do you have actual alarm activation events? In the UK, we also couple that sometimes with camera technology, so we can capture the actual intrusions and learn from that. Why are people, making these mistakes? Although in a lot of cases people do it intentionally, which is even worse. And some other aspects we're looking at as well is floating car data around the work site. So what is this sort of speed behavior of people around, the work site? All that is captured, as James said in the intro, in what we call our My Work Zones platform. And I hand it over back to you, James, for that one. Thanks.
Thank you, Roger. Altus has only recently brought your solution to Australia, so it's at a fairly nascent stage in terms of being introduced to the market, but you've got that track record and that history in Europe and in particular in the UK. I wonder if you could let us know how the relationship with regulators evolved from that initial stage of adoption to putting out 18,000 deployments last year. Has that support been good? Has it been crucial? Maybe talk us through that.
Yeah. So in the early days, what we focused on really heavily was the user, because we wanted to make sure the people who deploy it, if they don't want to deploy the technology and don't believe it makes a difference, you're pushing water uphill basically with that. But we've had really good support from Highways England, or it's now called National Highways, at the start. But what we've done is, as opposed to looking at regulation changes, we can take a long time. We've worked closely with the whole industry to actually create a level playing field, because this technology was really hard even to commercially adopt, because it's something new that doesn't quite fit within existing sort of commercial model. So we've worked really hard to create a best practice category that has been supported by National Highways. And that's basically how it sits at the moment. So it's called Raising the Bar. There's a series of Raising the Bar documents that don't just relate to traffic control, they relate to all sorts of aspects of how you manage work sites and roads in general. We basically work with industry to create one around incursion, prevention and management. And that's where our solutions sit. And that opens it up for other parties who provide similar systems if they come into it, but it gives it more of, for the supply chain wanting to use it, it gives it more of, it makes it easier for them to adopt it. So that's taken a few years to do, but it's now almost seen as a must-have requirement on site.
Yeah, I mean, you said that the original idea for this came in response to a tragic incident that occurred. I know it's difficult to prove, but would you suggest that lives have been saved through the adoption of this technology at some level of scale in the UK in particular?
Yes, a good question. It's like you said, it's a tricky one to call for us. So we have to rely. We can see obviously data, but data doesn't always show you what's actually happening really on site. You could only do that if there was a camera there, and in some cases we have footage of what has happened. But for us, it's all about the anecdotal feedback from people. And there was one quote on the screen earlier, but unfortunately we get this way too often where people say to us, it's been indispensable because we've had a high-speed vehicle coming through site or police chase, and that led to somebody jumping into the site. So there's been multiple occasions where people have said, look, we've been, we believe, that somebody's lives have been saved. For us, that's enough, because that's what we've set out to do. This is really about, yes, it's about data to improve things, but ultimately, if we can save one life by being able to warn people, then it's basically worth it. And in the UK, that's definitely been the case. And once that happens on a site, you see the adoption and the engagement of the workforce change massively, and then more and more ideas come out for further development.
Yeah, I think it's a fair comment to make that that our industry has not seen a lot of step change in innovation. And I think part of that can be slated back to the idea that, you know, entrepreneurs have been trying to solve single use cases and not necessarily looking at a site at a holistic level. So perhaps just give us a brief explanation of, you know, how the My Work Zones app can adopt future innovation as a platform. I mean, you mentioned earlier about some of the data, for example, that Angus was talking about. Do we see a future where multiple data sources can be brought in to help contextualize that risk better, and multiple smart devices can be added to the platform over time?
Definitely. No, with APIs and linking systems together nowadays, that is what has to be done. Because what we see a lot is you've got devices, and you might go to a traffic control company, they have 5 or 6 different logins to look at their variable message board, their traffic lights, our equipment. There's no reason for having all of this in different platforms. It can all be brought together, and that doesn't affect anybody's competitive or commercial position. It's just literally common sense, because users need to have a seamless experience. And I think that is, you're definitely right, James, and bringing all the data together, looking at what Angus says is what is happening around this work zone. We can look at what is happening from within the work zone, you know, the types of alerts or the perimeter of it. If you bring all that together, ultimately you make better decisions in the future and reduce the risk. So 100%, it is open, like platform style. That's the way we built it.
Wonderful, thank you. All right, I'll get you to stop sharing your screen, and what we might do now is flip to Sam, and I'll give Sam an introduction. I could shorten this, Sam, by just saying you're a smart guy, but I'll read the points and you'll figure out why I've just said that. So Sam Mason, welcome. You're a senior solutions engineer working for Nearmap. So Sam is a geospatial statistician with a particular interest in ecology and species distribution modeling. He has a background in tree canopy research using Nearmap visible spectrum and AI datasets, and is now part of the UNSW Ecostats research group, where he is currently a PhD candidate. He joined Nearmap, the Nearmap AI team in 2017, before AI became fashionable, as a data scientist, and is currently a senior solutions engineer helping customers get maximum value from Nearmap content. Look forward to your presentation, Sam.
Righto, thanks, James. I'll jump straight into it then. For those who don't know, we're Nearmap. We're an Australian startup out of Perth, started in 2007. We have over 10,000 customers around the world across 4 main countries: Australia, the US, Canada, and New Zealand. And we've got over 14 years of high resolution visible spectrum imagery. And when that comes to Australia, we cover over 95% of the populated areas of Australia. And we do that up to 6 times a year in the capital areas. And then we kind of stagger that down. So it gets lower and lower as you get down into the regional areas. And that gives us about 500,000 square kilometres covered on average every year. And that's almost 200 urban and remote areas. So having said that, here's what we really do. We take really beautiful, high resolution, visible spectrum imagery. Now, what you're looking at here is an example of that. Every pixel you're looking at here represents 7.5 centimetres on the ground. And I'll point out that's taken from 14,000 feet. Every pixel is time-stamped, and that gives us a unique online digital history, which is second to none in the industry. Quick look at our content stack. Our imagery there on the left is the basis of everything else. So we have our vertical, our panorama, our oblique imagery, which is the ones that we take out on the side. We stitch that together, we build 3D imagery, and we do our AI pipeline. Now here's a quick look at our 3D family. Not going to go into detail on this one today. We're going to have a look at a couple of these though. Texture mesh on the left. So obviously that's going to be building those 3D models, stitching together our imagery, that sort of stuff. And I'll jump over on the right-hand side there, digital surface model and digital terrain model, which has particular relevance with what we're going to talk about today. In our Nearmap AI family, what we do is every time we fly our planes, we grab all of our imagery and we pipe it through this AI system that we've spent the last 5 years building. And we do that for every single flight. So we have petabytes of data. What we're actually doing here is what's object detection. And we go and we look at things that are out there in the world. So we find things like roads, road markings, pools, solar panels, vegetation, roof materials, tree overhang construction sites, the list goes on. We currently have about 72 different classes of things that we find in the world at various stages of production level. We make that available within a couple of days of flying as well. We have that visualization option in our flagship product, which is a lightweight web application called Map Browser. And I'm going to show you some examples a little bit later on about that. And lastly, if your company's a little bit more tech savvy, we also supply these data sets offline, or you can integrate directly into APIs and pull that data into GIS platforms, whatever way you need to go. So having said all of that, let's talk a little bit about remote planning. Now, remote site assessment is really all about maximising worker safety, and doing that means planning for site safety. And IMAP helps here because our high resolution imagery and our world-class AI data sets work together to help you get to that outcome. Now, remote assessment leads to some obvious benefits. It's obviously process efficiency, cost savings, and reduced risk to on-site personnel. What it's really about is finding out what matters now rather than when you get on site. So things like site and lane geometry, things that matter like environmental conditions of the site, the slope, the aspect, the elevation, identifying potential hazards. You're going to want to look at things like vegetation overhang, where power poles are, minimum clearances, overpass heights, all of these kinds of things. You're probably going to want to know about existing speed limits on approaches, and probably locate existing specialised infrastructure like cycleways, bus lanes, that kind of thing, and flag already in progress local construction. And like, you might want to identify targets where you're going to have to do some temporary traffic rerouting. The point I want to make is that you can do all of this from your desk. Let's talk about what I'm actually talking about here and show you what it is that we actually have. So here's some examples of some of the categories of that 72 that I mentioned earlier. So when we fly, we go and we capture these things and they are available straight away. So let's have a look at some of them. Right here, we have cycle markings on the road. We pull them out straight away. We even get the cycleways themselves as well as those markings. And I'll point out too that our models are that good that they're robust to noise. You can see there that even that one in the upper right-hand corner there is even slightly occluded and we still pick them up. That's sort of where AI is at today. We have pedestrian crossings, manhole covers. And when you're going to look at a busy intersection like this, you're going to want to know things like where the navigation arrows are coming into that intersection. You're going to want to know the approaching speed limits, where the bus lane is down there at the bottom. And if you're interested, you can even get a point-in-time capture of the cars, although there's far better ways to do that these days. As I said before, our models are pretty robust. Here's an example where even when the lines and the markings are degraded quite badly, we can still pick those up. And in this case, this is Fox Studios actually in Sydney, for anyone who can recognise it. You can see how worn out and wiped they are, and we still pick them up even when they're a little bit in shadow. And a last example here in Sydney CBD, you can say we still get that bus zone even when it's actually really hard even for humans to see. Putting that all together, you might want to look at a site and start really bringing in our different AI layers to actually build up a really good idea of what's out there. Then we're going to bring in the asphalt, the road itself, concrete slabs in the area, maybe the locations of all the power poles in that area, and maybe all the lawns and vegetation as well. So you can really get an idea if there's lawns that need to be pulled up or verges that need to be put back in place when the job is done. All that kind of thing can be allowed for right at the start. So it's really about decision support and where AI can help you with that, and where Nearmap brings that to the table. But AI doesn't and shouldn't replace human expertise. But what it can do is it can help human experts make better decisions. So AI can really identify candidate areas of focus and feed that into preventative and predictive asset maintenance schedules, thereby reducing costs and improving outcomes overall. But let's get to the fun stuff. Show you some actual examples in our Map Browser product. So first, we're going to look at our digital terrain model. So this is what I mentioned earlier before. This is derived from our 3D work. And what you see here is an example. This is just an average suburban street in Kensington, in Sydney. And what I'm going to do here is I'm just going to take in a Map Browser here. I'm going to draw a line all the way down here, and you're going to see come up at the bottom there a road profile. You can see exactly in detail as I move down that road. And what we see here is this particular place has a drop of 8 meters over 80 meters. It's quite a steep drop. And that's the kind of thing you're going to want to know before you send your road crews out there with all their machine plans. What's interesting about this particular one is, as a consequence of that slope, you can see here on the left, I've got this split view running here in Map Browser. It's April in 2022, and just 11 months later, you can see the road here's nice and clean. Just 11 months later, we can get a really good idea of that road degradation that's happened. And that, in this particular case, it's happened for two reasons. Obviously, the stormwater runoff on that slope, And also this is a shortcut that runs up behind a school and cuts up from the Sydney southern suburbs, gets you onto the eastern distributor. So it gets pretty high traffic throughput. All right, next. We can use our stuff to actually monitor site progress at certain points in time and just have a look at sort of the in situ safety measures that have been put in place. What we're going to look at here is the extension or the entrance into the M8 down at Kingsford at the end of Gardeners Road. You can see here, this is just over a couple of 3-month period into 2020. And you can zoom right in here. You can see what's been put in there in April. You can see the immediate progress that's happened just in 3 months there. You can see the machine plant, where it all is, what's been done. You can even zoom out and actually see if there's anything or any changes to the local area that you might need to go and have a look at or take into account. Another interesting case is planning for approaching traffic management when you have limited site access. So this example here is up here at the Central Coast, a place called Wamberal. There's a very narrow 2-lane freeway that feeds all the upper Central Coast traffic south to Gosford, pretty heavily trafficked, and you can see here they've actually built a separate lane here to store to store the road excavation equipment. And the reason they've had to do that is because we've got this national park to the east here where Foresters Beach is. So that's the kind of thing you're going to want to know, again, while you're doing your site planning. Jumping ahead to some big ones, and we jump down to Melbourne and we look at the traffic rerouting that's been done around Anzac Station at St Kilda. This is a really good example, and I'm going to over here on the left here is where we have our available AI layers. I'm going to turn a couple of them on so you can actually see some of the things that we can grab. And you can see here, obviously, there's been a massive amount of work that's been done rerouting both the tram line and the actual traffic, vehicular traffic laneways there, as well as the changes to where the cycleways are and the oncoming speed zone. And lastly, the big one is Warringah Freeway. This is something that's come up every now and again. There's a lot of work going on in this in Sydney, and this is a really good case where you can look at the overpass height, change traffic routes, speed limits before and after, and changes to navigation markings. So if I just bring that one up. Go. And as I said, if we turn these ones on, turn arrows on and that, and you can see here, this is an example where prior to the work being done, this was an 80 zone, and you can see the lanes have been changed, the traffic reroute has rerouted, dropped down to 40, the line markings have changed over time. And what's a good example with this one right here is what I mentioned before about measuring that overheight. I'll just jump out here, and this is an example of our 3D mesh in the same area. And with our 3D tools, all of this is exact, it's all geo-referenced, which means I can actually just pull up and draw a line over the 3-dimensional mesh right here. And I can get a very accurate height of that overpass before I've even gone. That's 6.41 meters. So again, you can imagine the value of that, when you're working from your desk. So the last thing I'm going to show you here is if you're really cluey and you really want to go hard, you can pull all of our AI layers together, and you can even build your own little digital twin ahead of time if that's what you're interested in, and get that kind of interactive experience. This is the Penrith CBD area, and you can bring in all of our different layers. That's our 2D imagery. We know where the vegetation is and how high it is. We know where buildings are and how high they are. We also have the roof materials, and we have, most importantly, the poles. And that one, as you come in here, and I get this sort of interactive view of a perspective. So I look at this roundabout, I can get an idea here and say, okay, I've got vegetation in the middle of that roundabout at 6 meters. I've got some more here at 3 meters, etc., etc. I'm going to leave it at that. So thank you very much, everybody. That's all we have time for today, but I'm happy to take any questions, and thank you for that fire hose of information. Cheers. Back to you, James.
Thanks, Sam. And it's interesting that you brought up the Warringah Freeway example because earlier Angus was showing me some data about some of the behavioural changes that have occurred for the Warringah Freeway project. And it just happens to be one of the sites that we've been trialling the HRS solution on. And I think finally, in a serendipitous twist of fate, the chair of our Road Worker Safety Working Group is the head of safety for CPB, and it happens to be a CPB job. So an interesting choice of example. The question that I wanted to ask you, Sam, is that obviously there's been a huge wave of infrastructure investment across most of our metropolitan capitals and indeed in the regions as well. Are our cities changing quickly? You're taking very high frequency, high resolution imagery. Are you seeing our cities transform? And is there anything that's caught you by surprise in terms of the speed of that change?
Yeah, the answer to all of that is yes. But getting a cage is kind of like listening. We think of it as like having a stethoscope and listening to the heartbeat of a city as that construction really happens. The fast ones were the Barangaroo work, where our head offices are, and obviously the Crown Casino, watching that start and stop as they ran into things like asbestos and those sorts of things. One of the more fast ones is actually the one I showed just in that presentation there down at Anzac, the Anzac Station at St Kilda. 2 months, you would think that you wouldn't catch much difference in 2 months, but when we see, particularly those ones like Warringah Freeway, where it has such a major impact and there's so much being thrown at it, we see that changing quite a lot. We see a lot less change sort of as we move out to the regional areas. But one of the big ones that really gets impacted that we see is the vegetation. So watching tree canopy cover just getting like taken out, and even though it gets replanted, obviously that has a big impact as well. So yeah, we do love working in IMAP because we do get to actually watch the world go past pretty quick.
Excellent. And the other thing that we were talking about before we jumped on was sometimes you've got these software applications that do a lot of things, but there's perhaps some features or aspects of it that are underutilized. Is there something that frustrates you in terms of the customer base around underutilization? Is there something that you'd like them to direct them to understand better because you know the benefit of it? Yeah, for sure. I mean, I guess, everyone understands the benefit of, high resolution remote imagery. People have been using Google Maps and other people for years. But I think the term AI scares people off to start with. To us, it's just another way that we get data sets. How we do it is magic sauce and really doesn't matter. So I think that the frustration for us is probably we don't see enough people using 3D modeling and that kind of digital twins approach to really save themselves all that effort. And that technology is there. It's not new. This has all been in the last, 5 to 10 years kind of thing. I'd like to see more customers sort of leaning into that sort of 3D stuff that I showed there, because we've got, this stuff is exactly measurable and just the potential is just incredible, particularly in the engineering construction industry. And I guess the last thing is, like I said, we do have, quite a lot of this AI material out there, and we'd really like people to lean into that, and particularly using our APIs and that kind of stuff, because, we can only do so much. Our roadmap gets fed in by what our customers tell us they want next. So yeah, I might bring Angus in here, and I'm thinking, Angus, obviously you're being able to see the analytics from the vehicles themselves. I imagine there's a nice complement to have that visual representation of the change to build a better picture of what actually is going on for that off-ramp, for example, or in that Warringah Freeway example. The visual, I think, would complement the data sets, I would think, in helping to explain phenomena.
100%. I do remember when I started the company a few years ago, I was looking at EMAP, and it has got some stunning images, it's really high res stuff.
Mm-hmm.
Yeah. And as you were presenting, Sam, I was just like, we should really integrate those two together. So you're spot on, James. Yeah. And ultimately, the thing is, it's all about the context, right? There's a context before you start, your work site, for example. There's a context during the setup stage, and then there's context once you've completed it to see the change that particular piece of works have done to the road network. I think it's pretty clear that integrating between a few of the data sets is the best way to go. I think all the companies on the call have APIs that allow that to occur, but I suppose what we're doing wrong is we're perhaps forcing that over to the transport authorities. We should come together.
Yeah, and we might jump into some Q&A from the audience. We've had a little bit of interest come through in the form of some questions. And again, I might stick with you, Angus, just for the moment. There was a question about whether we call it kinematic data, I think, the vehicle data can detect things such as potholes, so vehicles hitting potholes. So perhaps we'll just sort of plant that question in a broader question, which is, what else do you think the vehicles could potentially detect, if not now, then over time? Do you see the sensor evolving in terms of, do we ever get to visual modeling through the vehicle, for example?
Yeah, I mean, the reason I'm in Hong Kong is actually because I'm a flight to Munich tonight. We've been working with BMW and a few other OEMs, largely around what we call ADAS intelligence, advanced driver assistance intelligence. and it's using so at the moment we've got the head unit, and that processes a whole range of data, but we're using accelerometers and gyroscopes. So the direct answer to the question around potholes is yes, you can figure out road rough. Indeed, we did it after the Lismore floods and a few other places, and it basically pitch roll yaw is what a gyroscope will give you. So sort of this movement and an up down movement. So rideability. What we're going to with ADAS with BMW Group is we're writing specific code that takes out image detection from the inbuilt cameras on vehicles. Compass's core fee is that instead of paying heaps of money to deploy hardware on the ground, when usually we're trying to censor, cameras and trucks anyway, let's just use the cameras on the trucks and the cameras on the cars that are deployed from the point of manufacture. So what we're doing is essentially picking up the camera and the radar data from BMW vehicles, and they're going to constantly be surveying. There's about 300,000 BMWs in Australia. They're going to constantly be surveying the road network and picking up line marking, signage, potholes, traffic lights, all that sort of stuff. But that's due for release somewhere around the middle of July.
Thanks, Angus. Roger, I'm going to go to you in a sec. We've got a question about trials of your solution in Australia that perhaps I can better answer. But before I do that, you're on the ground in Sydney at the moment. You've managed to visit a few work sites in a few states. Do you want to draw any kind of contrasts between traffic management, work zone management in Australia versus the UK? I imagine there's similarities, but perhaps some of the obvious differences.
Yes, good question, James. The interesting thing is we operate in North America, across Europe as well. Every country, unfortunately, does it differently, which I guess complicates things for OEMs as well, and everybody. But I think overall, I'm quite impressed how things are done. I mean, one of the main differences that we've got, we do things very differently to continental Europe and the UK, but we have a tendency to try to close parts of the carriageway, which in some markets is like swearing in church, I guess, to do that. Oh dear, we close the carriageway. But if you close the carriageway, you usually get more things done, but you inconvenience the road user, unless you have a really good diversion route. So I think that's one of the main differences that I think we've got. It's still, even in the UK, it might only be 10% of the volume, but I think that's one of the big differences. And what we see across Europe is that more and more authorities are going, look, we need to make sure things are safe. And so we're going to work more and more on the full carriageway closure. And that could be a small section. It's not like a massive, 10, 20 kilometer closure. But I think that's one of the main differences I've seen, that there's not really a tendency, I think, locally here to do that, which is fair enough. But with that, obviously, you've got more risk of people working very close alongside traffic, and if there's just a cone there, it's not going to stop anything. So that is one of the main differences that we've noticed.
Yeah, there's certainly an inherent tension, I would say, between the customer experience or journey management, the road user, and then what is an appropriate level of safety. And it's a tension that I don't think we've actually resolved, but I'm looking forward to having large and scaled empirical data sets to help support the arguments for and against. To Anthony from the audience's question about trials, we are conducting trials, have been doing that for a couple of months now with some of our key customers on the east coast of Australia. And the purpose of doing that is to really get the solution right and appropriate for our markets. As you can imagine, it's a step change that needs to occur in terms of the skills level of the staff and the workflows. And we've seen too many examples of products being launched without proper forethought. So really making sure that we get the feedback from our clients and truly understanding the product market fit and then the implications for the safety of our staff. But we will scale. And if anyone wants to get in touch in relation to that solution, I would call out Beth Lilford from Altus Group, who's our head of digital. So that would be your best point of contact. Okay, question here from Catherine. I'll stick with you, Roger, for the moment, is really about the API side of things. And does your application draw data from other sources. Google Maps has been mentioned. Perhaps you can talk to the current data sets that can be brought in to that spatial representation of a site, and then perhaps some of the thinking around what you could see coming in the future.
Yeah, no, that's a good question. So we use a Google backend, the mapping for the geozoning. That doesn't have to be mega accurate, because work sites, you can plot them out quite easily in the geozoning. But what we do pull in is the traffic data or floating car data, and we can automate that process. So we can link it to devices going live on a site. So when you deploy traffic management at 9 in the evening, we can literally automate the process as soon as they go live, point to point. You start to automatically look at what is the traffic speed through that, and therefore the compliance. And we've used that in a few markets, like for example, Sweden. Our customers have been very proactive with this, because it shows them, yes, we can put radar detectors there, and that's something we could do. But from a high level, it allows them to look at all their sites. Are people complying with the speed limits? And if they're not, what do we do actually to bring the risk down? Do we need to put more signage up, or do we need to do other things to slow people down? And I think that is one of the key integrations that we've got that is quite successful for our client base.
And of course, I think the Google Map or the Google Analytics data is limited from a driver point of view, a vehicle point of view, to volume and speed. I mean, as we're talking, occurs to me that there's some richer data sets available, and I do wonder again, Angus, in terms of collaborating, how much value would be able to be added to see some of these hard braking and swerving events in and around work sites. I would imagine that would support this concept of active intervention around risk.
Yeah, I mean, one thing we did do, a lot of the transport industry is like at the top of it is government led. The only other section is like generally private road operators like Transurban or Eastlink or what have you. What we implemented to encourage the sharing is that we give what's called a sub-license. That means that whoever has our core license, like Transport for New South Wales or TMR in Queensland, can sub-license other parties, such as Altus Traffic or whoever they've contracted, to basically allow our data, including the APIs, all into other front-end products. I think that it's a big thing that we need to work on. There was a question in the chat around what is the biggest challenge for ITS. The simple answer for us, at least in connected vehicles, is education. And sometimes a part of that is the visual aspect, which I think is where we need to meld stuff together. And it shouldn't be, it's not hard technically, but it's hard visually. To get the design right and to make the, actions, the data useful is actually quite a challenge. And it takes some pretty, persistent brains, I might throw in there as well. But it's something that we should do, and that is available now from both our product, but indeed it sounds like with the 3 others on the line as well.
Excellent. Yeah, it sounds like there's a lot of opportunity as some of these, how do we say it, S-curves can collide to create new use cases. So really excited about that. Look, Sam, there are a couple of technical questions here around Nearmap. I think there is a strong push for you to start bringing in external data into your interface. But I will let you respond to those questions just in the interest of time. We might put a button on the audience Q&A at the moment. Any unanswered questions, I think there is a commitment that people will get back to you. But the other thing I wanted to mention too, for anyone who maybe has missed this webinar and thinks it would be of interest to them, if you know people that it would be interesting for, it is being recorded, so you will be able to share that or rewatch it if you're so inclined in the future. RA will make that recording available. And I want to thank Roads Australia and their team, Royce and Chloe as well, for hosting this event and for their continued interest in putting a spotlight on road worker safety. It was, when I first joined this industry, it never really got much attention. And it's been great to see the attention that's been given to it over the years, to the point where it's become one of their #1 policy priorities across industry. It's clear to me that there are significant opportunities to leverage data, and I hope people on the call, if you haven't had any exposure to just this small sliver of solutions that are available, that it's got you to start thinking about how you can understand risk and manage risk better. And there's three things that I kind of see in the combination of presentations that we've seen, is that you can potentially understand this risk before you go to a site. You can understand in much more detail what your site is likely to give you over and above what's available from a normal conventional plan or satellite image or even a site visit. It seems to me there's a lot more data that you can leverage in advance of going to a site, so you can plan it effectively. With Roger's team's solution, to be able to detect some of those risks in real time as you are at the site, and to be able to convey urgent warnings to road workers who might be able to take that couple of seconds to make a decision that will save their life or save them from injury. So that concept of active intervention, to be able to see the movement of vehicles in and around work zones and work out whether the setup that's in place is appropriate for the level of risk that remains from those third-party drivers. And then, of course, in hindsight, you've got this empirical data set that's available for you to be able to evaluate whether particular treatments are having the desired impact. Are we able to reduce the speed of motorists through work zones? Are we able to reduce the concentration of hard braking events at end of queue or swerving events or things of that nature? So I see a lot of opportunities just in the three solutions that we've heard today. And I want to thank you again for your great presentations and, of course, your time. In lieu of a speaker gift for our panelists, we are going to donate, or RA is going to donate to a charity. And that charity, surprise, surprise, is the Sarah Group. If you're not familiar with the Sarah Group, Sarah stands for the Safer Australian Roads and Highways Group. It was established by Peter Fraser after his daughter was tragically killed on the Hume Highway back in 2012. As a consequence of that tragedy, he and his family decided that they would contribute to improving road safety outcomes through policy development, community education and advocacy work. And I know we and Roads Australia are delighted to be principal partners in supporting him in that aim. They are behind National Road Safety Week. You would have seen plenty of yellow ribbons and messaging, and I'm sure your social media is being flooded with all of that material, and it's delightful to see that that's just grown to be such a big event every year. So again, let me thank you all for your time, and I wish you all a wonderful afternoon.
Thanks very much, James.
Thanks.
Pleasure to be here.
Thank you.
Thanks, everyone.